Welcome back again to my YouTube channel. Part 2 of our discussions today on direct variation by yours truly, SHERLINA A. AGCOPRA. So let's sit back, relax, and enjoy our math. Okay? So let's get started. Okay, this time, let us see statements translated into equations, a table of values, and a graph representing the direct variation. Study the example below. Okay, we have this table under the statement and under the equation. So let's read the first part. Z varies directly as y. How do you write it in equation form? Z varies directly as y, rather. So Z is equal to K times y in mathematical equation. Okay, the other one is P varies directly as quantity Q, or in equation, mathematical equation, you have P is equal to K times Q. When you try to find or look for the value of K from this equation, you just translate it to K is equal to P over Q. That's it. So as you can see in the equation, there is K, which is the constant of variation. Okay, next is study the table of values below. You have X and Y. For X, you have 1, 2, 3, and 4. It's increasing. And for Y, the corresponding values of X and Y, you have 1 and 5, or 1 is to 5, 2 is to 10, 3 is to 15, 4 is to 20. That's it. And for the values of Y, you can notice that it is also increasing. 5, 10, 15, and 20. So from the table, as the value of X increases, the value of Y also increases. Therefore, the table of values shows a direct variation. It can be represented in the equation y is equal to K times X, where our K here is the constant of variation. Okay? Okay, from the graph here, you have the values of here, the time, 1, 2, 3, 4, 5. 1 hour, 2 hours, 3, equivalent to the time, t. And in the vertical, you have 10, 20, 30, 40, up to 50 for the distance t. Based on the graph, as time increases, the distance also increases. This means that the graph shows a direct variation, which can be represented in the equation d is equal to kt. The graph of the direct variation is a straight line. Okay. So if you can see a graph looks like this, then it is an example of direct variation, a straight line. Okay? Okay, try to look at this one again. So now let us solve simple problem involving direct variation. So study the example below here. Let's read. If y varies directly as x and y is equal to 12, when k, or rather when x is equal to 4, find y when x is equal to 12. Find constant k of variation. And b, find y when x is equal to 12. So step 1, find the constant k of variation. So from here, you can make a formula that y is equal to k times x, or y varies directly as x. So this is now your guide or your formula. So when y is equal to 12, you have to substitute the value of y, 12. And for the x, which is here, which is 4, all you need to do is to get the value of k, the constant of variation. So using the mathematical equation to solve for k, you just substitute the value of x and y. So in here, you have 12 over 4, where our k now, or the constant of variation, is 3. Then, when you find the value of k, you have to find again the value of y when x is 12. So all you need to do is to substitute again the value of k to the new formula of this statement here. Y varies directly as x. So given x is equal to 12, all you need to do is to substitute. So from here, you have a statement, translate to variation equation by substitution. Y is equal to 12 and x is equal to 4. So divide both sides by 4. So the equation of variation now is y is equal to 3 times x. So since the value of x is 12, all you need to do is to substitute from this equation. So for step 2, you have values of x, 12, substituted to the equation here, you got the value of y, which is 36. So the value of y when x is 12 is 36. Okay? Very good. Okay, we're almost done with the topic. So let's apply our knowledge on direct variation on this problem. Activity 2, in your modules, answer me according to type. So let's read the direction. Read each passage and understand the situation. Then answer all the questions related to it. You may show your solution on a separate sheet of paper. Okay, let's read the problem. The Math Club launches a recycling campaign of waste materials during the Math Month celebration to raise students' awareness of environmental protection and the effects of climate change. Every kilogram of waste materials earns points that can be exchanged for school supplies for the winning section. Paper, which is the number of one waste collected, earns 5 points for every kilo. The table below shows the points earned by grade 9 NARA class for every number of kilograms of waste paper collected. So as you can see, the number of kilograms N is 1, 2, 3, 4, 5 with the corresponding points P for 5, 10, 15, 20, and 25. As you can see, the number of N, or the number of kilograms of paper N, is also increasing. And the points P is also increasing. Okay? Okay, from the problem above, we have 3 questions to answer. One is, what happens to the number of points when the number of kilograms of paper is doubled? For number 2, how many kilograms of paper will the grade 9 NARA class have to gather in order to raise 300 points? And for number 3, what mathematical statement will relate to the quantities involved? Okay, you may answer this problem in 5 or 10 minutes. Okay? Next is your assignment. So while answering, I have to post first this assignment for you to answer it at home. So after 10 minutes, you can pass your paper. But I want to read it first, the things to do at home. Okay, express the following relations as equation or formula. Number 1, water pressure P varies directly as the height h of the water. Number 2, the area A of the square varies directly as the square of a side S. And number 3, the cost C varies directly as the number n of pencils is written as. Okay, for number 5, 4 and 5, solve the unknown values. Okay, that ends our topic for today. Okay, so you may pass or submit your paper via online after 10 minutes. Okay, thanks for listening. Please do watch my other videos and don't forget to like, share, and subscribe my YouTube channel. Bye! God bless everyone.